responsibilities of developer shifted to two major responsibilities. One is modeling, data modeling, and the other one, querying the database. Querying includes like inserting, updating, deleting, and also asking questions and getting answers. So this is the first skill, which is the data modeling. So in data modeling, what does it mean? What do we need to do? How do we start? What is it first? Let us first try to define it. What is a data model?
Analyze the requirements.
Sorry?
Taking the requirements.
Taking the requirements. Taking the requirement is one of the steps of building a data model. But what is it first? What is a data model? Yes, please.
Identifying the entities and the relations between them.
Identify the entities and the relationship between them. Yes, this is basically at the end the outcome, what we find in a data model. And what these entities represent?
Objects.
Objects or concepts and objects and concepts that we find in the problem we're trying to solve. Okay, so let me go through some definitions here, first of all. So a data model is collection of concepts describing the data that we want to store and manage in the database. And it gives us the logical model. Remember what the data looks like. What are the concepts? What are the concepts kind of mapped to entities? What are the entities? What are the attributes of these entities and how these entities are related? Not how we will store them, what format we will use, how physically will be stored. That's not our concern. So it stops at the logical level. It's a logical model. It's just, that's, sorry? Basically, we identify attributes and we identify entities of those attributes and we identify relationship between these attributes, okay? So what we find in this model, in this logical model, we find two things, two major things we find in this model. We find the structure, which are basically the entities, their attributes and relationships. And we also find constraints. This is very important to capture in the model. What do we mean by constraints?
Data types, conditional,
Like for example, like data types or some column, the value of some column should be unique. Some values are mandatory, others are optional. For example, these are, if we look at one entity at a time, there are some constraints at the level of the attributes of the entity. Okay. We can also look at what is known as a referential integrity constraints. For example, we cannot create an order before creating a customer. We have to create a customer first. We get the ID of the new customer, and then we use that ID to create the order. And it has to be in that order. I cannot go and insert an order for a customer that does not exist. And again, if I have a customer, I cannot delete that customer if that customer has orders. I have to first delete the orders, then come and delete the customer. Those are referential integrity constraints. So these constraints are defined in the model. Now, the relational model, this entity relationship model, is just one of the models. I just want to stress this, especially that we are no longer in the monopoly of the relational model. There are other models. Relational is just one of them, but the relational is very, very powerful. Even if you will be using some other database, you can start with the relational model. Okay. For example, if you go for a key value database, you can still use the relational model. You have the key, could be, for example, an ID, and the value could be serialization of an object. But the structure of the object, how do you find what is inside this object? What's the schema of it? It could be defined in a relational model. So relational model is still very, very powerful. And plus, whether you will be doing it or not, in the programming, you will be doing it. Remember, in programming, the objects-oriented programming is still very dominant style of programming. And as I explained before, like our program will be made up of objects And before we create this object, we create classes for them. And guess what? Classes that you come up with, 99 or 98% of them, or let's say 90% of them, they store some data that you care about, that you want to persist for future use. And guess what? Those classes that you have created, you will find the corresponding entities in your database to store them. So relational model is still very relevant. And by the way, you can tackle it either from software engineering perspective, if you have that background, or from a database developer perspective, if you don't have that object-oriented experience. Okay? All right. But just be aware that there are other models, such as the graph model, the documents model, arrays and matrices. This is very widely used in machine learning contexts, in maybe scientific applications, lots of arrays, lots of matrices. Those are also data models. And they might have their own special kind of databases that deal with them. One of them is, one team is looking at time series. This is a special type of databases, okay, to manage that particular type of data. Okay, graph, as I mentioned, graph also, there is special data structure that has its own data management systems. Okay, and in here, these are very different. These are, the relational model will not help you. These are very, very different data models. No? Okay, but the good news is you don't need to, before, whenever you want to store some data, whatever the format of it, you still need to somewhat squeeze it into the relational model. But these days you don't need to. If your data is really a graph, keep it as a graph. If it's arrays and matrices, keep it as a matrix, store it as a matrix, and retrieve it as a matrix. Okay, so you don't need to do this transformation back and forth between relational and these models. Other than that, you can go for relational. It's still very applicable to many scenarios. It's very versatile. It's very powerful modeling tool. But it's not the only one available for you. Now, for doing this data modeling, it is really driven by experience. You have to do it to really learn how to do it. Okay, but there is a process. You need to learn the process. You need to learn few concepts, and you need to practice it. That's the only way to really master this. Okay, what is the process? How do we come up with this data model? Any idea? So before we go into entity relationship.
Analyzing the requirements to get what we want.
Yes, that's the first step. And guess what? That's the most critical step. Because if you got the wrong requirements, you will get a wrong model and everything will be wrong from that time onwards. Okay? So what it means by gathering and analyzing requirements, what do we mean here? What is the outcome? That's the how. So the how to collect is that you meet with the users of your application. You can sit with them, spend some time with them, see what they do, how they work, what documents. Let's say if it's a manual process, you see what document they are using now. Maybe they are using some Excel spreadsheet. You get them to show you that Excel spreadsheet. If they're using some forms, manual forms, see these manual forms. These are very important sources from where you will learn this data model and design your data model. Sometimes they have some existing system. You also, of course, need to study it. But at the end of the day, when you say, I have collected the requirements and I have analyzed the requirements, what is the evidence that you did so? And what is the outcome at the end of the day? What you have at your hand once you are done with requirement analysis? The use cases. So if you don't have use cases at your hand, what does that mean? You have not done any analysis of requirement. Now, what are use cases? It's one of the tools, but very, very powerful tool to really capture the requirements and really capture them in a meaningful way and It's a very powerful tool to do so. So what are use cases, first of all?
The main functionalities.
The main functionalities. Yeah, sort of. What is a use case? Scenario is not the use case. Scenario is how the use case will be achieved. Scenario is an interaction between the system, the user, and the system to achieve the use case. So what is a use case?
It's defining the needs that to be achieved.
No, business requirement, it's a requirement. But as I said, we capture the requirements as use cases.
It defines
So what is the use case?
How the user will use the system.
No, that is a scenario.
need from the objects.
What you need from the system. Okay, very good. What you need from the system. Another way to say it,
The object communicates with this use case to do some function.
no, that's the how. So use case, keep this in mind. This is very important. Use case equal goal. Yeah? Use cases are goals. So how do we come up with these use cases?
By knowing the functional requirement.
No, before that. No, what I mean, you will go and talk to people and collect this information, but when you go back to your office, you really need to analyze it, analyze the requirements. What I mean by analyze the requirements? You need to find...
The relations and...
No, not related. This is, by the way, this is a very precise process. Requirement analysis, I know when we say requirements analysis, it comes to mind something fluffy, non-defined, like very vague. No, it's very, very clear process of how you come up with good quality requirements. The first thing, you identify what this guy is. Your actor, not user. We call it actor, okay? You define your act, you find out your actors, and what else you find? These actors will come to your system. Why they are coming to your system? They have needs. Another way to say it. No, another way to say it. They have goals. When they come to your system, they have something in mind they want to achieve. That thing in mind they want to achieve is the use case. Exactly the use case. I'm sure you go to Banner not because you have nothing to do and you are bored. You have a long day, and then when you have a long day and you want to relax, what you do? You go to Banner. Is that what we do? When we go to Banner, why are we going to Banner? Tell me.
We have a goal.
We have a goal in mind. What is one of the goals? Why are you going there? Sorry?
What is the home model assignment?
No, Banner.
Use collection, add the drop.
Very good. That's the goal. That is the use case. Add course. Add course or enroll course. Register. You see here, this is very important to use the terminology of the domain. Don't invent new verbs. Okay? This is the power of software developers, by the way. When they come to some certain domain, they will learn that domain. They become like, you cannot distinguish them from the other people of the domain because they quickly pick up the terminology. It's very important because every domain has its own terminology, and it is very important to keep that terminology. And by the way, reflect that terminology in your system. Yes? Okay, so don't say add. Although in the implementation you might have add, but in the when you express the goals, express them using the terminology that the users are using, the domain experts, the people you're trying to build the system for, use the same terminology. Yeah. For example, if you are talking to accountants, as an example, they use account. And therefore, if they want to put some money in account, they don't say, I want to put some money in an account. They will say credit. If they want to take out, they will say debit. Okay? If you go to a bank, they will say, okay, account, this is deposit, withdraw. So you use the same terms. Okay? So here, register, Register course. Yes, what else? Drop course. What else you go there for? Get transcript. What else?
Calculate GPA.
Which is part of the transcript. Do you have this as a separate function? Or yeah, okay. GPA. Calculate GPA. Usually it's a verb. Calculate GPA. Or get GPA. Not calculate GPA, get GPA, let's say. Maybe get schedule, and so on, okay? Because in here, at the end of the day, you need to start from the goals. Then, from the goals, what you do, even just expressing these goals, you already have some clues about the concepts and the entities that you'll be dealing with. Then once you do the goals, what's the next step? So for every actor, so actor will be, for example, in our case, student, faculty, administrator. For example, in Banner, how many actors we have? 3 actors. Actors, again, the actor is what? What is an actor? Is it a user? What is an actor? It is a role. A role. Yes? What is the use case? A goal. So just keep this in mind. This is very important. So when you go to a particular system and you want to analyze it, of course you talk to people. People will not tell you this. You have to analyze and infer this, like kind of derive it from all the talking you have been doing with them, all the documents you collected from them, all the watching you have been doing, watching how they work, what they are doing, all the interviews you did. At the end of the day, you have to squeeze it and process it and do whatever you do with it and squeeze it. And what you should get out of it? The use cases. What are the use cases? The roles and the goals. And you start from there. If you don't start from there, you might be building something else that will not deliver what the users are expecting. Because at the end of the day, why the users will be coming to your system? At the end of the day, once your system is ready, why they are coming there?
Because it achieves their goal.
Achieve their goals. Thank you very much. Okay. So we have to go goal-driven, and we start, the whole process starts from there. If you pick up the wrong goals, or you missed the goals, or you misunderstood the goal, then everything is madrub from there onwards. Okay. So make sure you identify the roles, not the users, the roles. Because a user can have, by the way, multiple roles. Yeah? You identify the roles and then their goals. Yes? And so, for example, for the role in Banner, for example, there is a student role, there is a faculty role, and there is the administrator role. 3 roles there. And then for each role, you specify what are their goals. And you put it in a diagram like this. Very simple diagram. The roles like this little skeleton there, and here is the goals. Okay, and this is your diagram. What's the next step? Once you have the roles and the goals, the roles are called actors in UML. By the way, this is a UML language, Unified Modeling Language. It's a unified way. Once you do this diagram, people will understand what you're talking about. They understand that this little skeleton there is basically a role. And what you put in this kind of circle or oval, you are putting the goals. Okay, and this is called the use case diagram. Okay, this is from where you start. And of course, every step you validate with your users. So you are not missing anything. Okay, what's the next step once you define the use case? For each use case, you define the scenario. So what is a scenario? How to achieve the goal. How the goal is achieved in the context of a computing system? Through
Through
interaction. So the user does some action and the system does some kind of reaction. Okay. For example, for register course, what is the scenario?
the system shows the courses.
Okay. Okay. Assuming that the user already logged in, okay, we know who the user is. What do we do? Display available courses.
User selects the course.
The user selects the course,
Add the course.
and the course is added to the user registration. This is what the system does. So the system, you see the interaction starts in this scenario from the system. System provides the list of courses available, not courses, we need to be careful here, list of sections. Okay, list of sections. That's the first step. And then waits for the user to select one or multiple sections. I'm not sure how it is the user experience. But in here, the user experience could be one or multiple. You can register multiple courses. Let's say keep it multiple. You select the sections you want to enroll into. And then, basically, you specify what you want to enroll into. And what the system will do? Will add those registrations will add these sections to your registration. Is the scenario done? That's it, the scenario done. Sometimes you might have multiple scenarios. There is the happy day scenario and there is the bad day scenario when there is exceptions. How do you handle exceptions? Okay. So for example, the unhappy day scenario could be like some sections are closed. So the sections that are closed, you just display a message saying sections are closed and show the maximum capacity and the actual enrollment, for example. Okay, so a use case can have one or many scenarios. Typically, it has one happy day scenario, where everything goes fine, there is no exception, and there is the alternative scenario when things go wrong, and you do this for every use case. Okay, the interaction between the system and the user and how each goal is achieved for every use case. Yes. Now, based on the use cases and based on the scenarios that describe the use case, so the requirements are not just a bunch of text. If you just write the requirements like this, just the comments, whatever notes you made during the interviews, whatever you observed, whatever you saw in existing reports or documents, those are not requirements. Yes, you collected the requirement. Did you analyze them? No. What is the output of analysis of requirements? What is the evidence that you did your requirements analysis? You must have at your hand the use case diagram and the scenarios. Otherwise, did you do the requirements analysis? No, you did something else. Yes? Then, from those requirements that you collected, what you will start doing?
Getting the objects.
Now, what I mean, this is the first step of data modeling. The first step of data modeling is requirements analysis. Based on those requirements analysis, you go through them, and hopefully you have spent some time doing this. So you start extracting the major concepts, usually nouns that appear in those requirements. Okay, those nouns are more likely to become your entities. So just looking at this, the nouns could be entities. So here, course, definitely this is an entity. But here, register a section. To be more clear, you see here, even the requirements, you might do some couple of iterations. You come with first version, you go to your users, you discuss with them, is this what you mean? Is there any gap? Does this make sense? Did I miss anything? It's very, very critical to have that feedback. and you refine it. So a couple of iterations, and then once you are happy with it, you can move on. So definitely at certain stage, hopefully you realize that you are not registering a course. What are you registering? A section. You see here, you refine your requirements. But definitely you have two concepts here. You have a course and you have a section. And these actors or roles, most likely they will also become entities. And within your scenario, the things that the user is given to the system could become entities. And the things that the system is giving back could be also an entity. Yes? And you start putting these high-level concepts. Initially, you just put the concepts. Some of them will start repeating. Of course, you don't repeat them. You say, okay, of course, I already identified it. Khalas. Let's move on if there is any other concept that I need to identify. Okay? And you just put them together in a conceptual diagram. That's the first step. Conceptual diagram does not have a lot of details. Just the high level entities. So, for example, I have here course, I have here section, I have here, let's say, actors. Most likely they will become entities. I have student, I have faculty, I have admin, I have, let's say, classroom, I have schedule, because it will come at certain stage, get schedule, transcript. Whether they will become entities or not, we will see. But in the beginning, you just put them, those major concepts, you put them, you give everyone a box, and you start to think what are possible relationship between these. Okay? Don't go into the attributes yet, just major concepts and the relationships. This is called conceptual model. It's still just concepts and how they are related. Yes? Okay, so what's the relationship between a course and a section? No, just two. Like we just concentrate binary. Just focus on these two concepts. So course has many sections. Okay, so you can put a line between them, and there are different notations how to do multiplicity or cardinality. In database people they call it cardinality, and in the software engineering people they call it multiplicity. Same concept. Multiplicity is more accurate according to my reading in terms of kind of English, and even in terms of meaning. Okay, multiplicity means how many for a course, how many sections I might have. So definitely there is one too many. So I can put this kind of. There are many notations. I think this is called the crow notation. You know, the ghurab has these three legs, and there is another notation that is like kind of something like this, infinity, kind of, yeah. There are many notations in here. Depends. Let me see what this guy are doing. I have some example here. This is one of the. Yes, this is using this notation. Can you see here? Using this crow notation. SQL Server. Let me see if I can get it running. SQL. It's another diagramming tool. It uses a different notation, but I think this one is quite famous, popular. Okay. Microsoft one, they are using a slightly different notation. It doesn't matter. Okay, going back to this. Okay, so in here, course and section. So I can have here basically 0 to n. Yes, because some courses don't have any section. They are not offered, but it's still a course. You get what I mean. If you are confused, you go back to your business people and get the information. You are not making things up. You're just trying to describe it and capture it in a model, in a technical model. Okay? Don't expect your users. Of course, they will really be impressed once the diagram is ready and you can explain it to them. They never spend time like trying to formally capture capture it in a model. But if you are not sure about something, you go back to your users and ask them and get clarifications. Don't make things up and just do it yourself. You really need to, if things are obvious and clear, you go ahead and do them. Once everything is ready, or once you have an early draft and you know what you're talking about, not an early draft and you're still lost, an early reasonable draft, you go and discuss with them, is this what you mean, is something missing, and so on. It's very critical to really keep that interaction with users as you move forward. Okay, now a section. What's the relationship with the course? Can a section belong to multiple courses?
One course.
One course only. Okay, so the relation here is 1. So a section has one course, but a course can have zero or n sections. Yes? Okay. Moving on. Now, students and a course. Is there any relation? Are you sure? Is there any relation between a course and a student?
Yes. He registers
He doesn't register courses. Do you register courses? You register sections, not courses.
But the section belongs to the course.
Belongs to the course, not to the student. Yeah. I cannot get to this. There is no direct relation between the course and student. These are two totally independent concepts, have no relationship between them. The relationship goes through the section. Are you following?
Yes.
There's no relationship. So I can start doing binary, take two concepts and analyze. Is there any relationship between these two guys? Yes. Put the relationship first and then start thinking about multiplicity or cardinality, same concept. Okay? So now between student and course, is there any relation? No relation. Between a student and a section? Yes, there is a relation. So students, how many sections they can have? Many. This is many. Okay. And then in here, how many sections a student can have? In a particular semester, let's say. 0 or n. He's still student or she is still student, but they are not taking any section. Or at the beginning of the semester, they haven't registered yet. So it could be 0 sections for a particular semester. Now a section, what's the relation with the student?
Many students.
Many students. Definitely there is many, so I put the many sign. And then I do the multiplicity. Is it 1 to many, 0 to many? What is the relationship here?
0 to many.
So 0 to m. So I just use two different letters because they are not the same. Okay. So let's say a student can register, let's say maybe 5 sections, 3 sections if master, or 2 sections. A section can have maybe 20 students, 40, 50. So that's why I put here n and on the other side m, just to make it different. So the relationship here is mn relationship or many to many relationship. Okay. In this, the first relationship, what's the type of the relationship?
1 to 1.
1 to many. Okay. 1 to many, plus we can go and dig deeper into that many. Is it 0 to many or 0 to n or sometimes 1 or sometimes 1 to 5? For example, car and wheels. They will 1 to 5. That's it. You cannot have more than 5, especially for cars. We don't need to put n if we don't want to. Okay. We can keep it n. It's good enough. And if we want to be even more precise, no problem. We can be more precise and put a number if we are sure that's the maximum we can have. Yeah, but better just if you come to 0 to n, you are already in a good shape. Yes. Moving on, faculty and student. Any relation? No relation. There is no direct relation between these two concepts.
But course faculty.
Course and faculty in relation. If we wish, although I don't think it's managed in Banner, but in some sophisticated system, we could have a relationship. For example, we can say faculty and a course, and you can say capable of teaching or can teach. Okay? And I can have a relationship with the course. But this is not, by the way, not managed in Banner, but maybe it's managed in the head of department's mind. He knows the course and knows the faculty, and they say, okay, this guy can teach these things, but he can be captured in a system. In that scenario, there is a relationship. Now, again, don't make up things. Go back to your users and ask them, do you want to manage this relationship, or we just ignore it? They will say true. They might make a decision. Sometimes they make it, because remember, you are starting to do the design. And design, there are decisions. Some of them you will make, some of them you make based on what you understood. And some of them, don't make them up. You have to go back to your users and get confirmation. Yes? Okay. So let's keep it simple, but as I said, there could be a relationship. Capable, this course can be taught. If I have a course, I can find out who can teach it. And if I have a faculty, I can find out what they can teach. Okay? Now, between faculty and section, any course, any relationship? If there is a relationship, I put the line. And then I do the second level of analysis. Okay, section, how many faculties can I have? Well, usually one, but it could be many. Yeah, if you go to medicine, you'll be surprised. One course, many people teaches. Yeah, maybe 2 weeks this guy and the other week the other guy and so on. So because remember, we are building a generic system that can accommodate all scenarios. Yeah, so there is a many here. Yes, and what's the section and faculty? It could be 0 to n, because initially we could create a section without faculty. Yeah, many times it happens, yes, to be decided. And then faculty and section, 0 to m. Okay, there is 0 to m. Yes, that's basically the relationship. Okay, admin, let's say admin. Admin is the ones that, let's say, configure the rooms. If there is a new room, they go and add it. If there is any configuration in the system, they take care of it. So what do you think? Any relationship between admin and student? Zero relationship. Admin and a course? No relationship. Admin and faculty? No relationship. Okay.
So we can remove the admin.
No, we cannot remove the admin, but basically there is no relationship so far. It's fine, we keep it. Okay, we keep it for now. Yeah, and so on. I'm just trying to give you the process. So you went through your requirements, you analyze them, you translate the requirement into use cases, having actors and use cases. Use case is a goal. Then for each use case, what did you do for each use case?
Scenario.
You define the scenario, which is the interaction between the user, the actor, not user, the actor and the system to achieve the use case. And how many scenarios you could have per use case? Multiple scenarios. One is a happy day, and the other ones are to handle exceptions. You did your analysis, you validate with your users, you are happy, you go through. By now, you can already know lots of things about the system. You learned the domain, lots of things in your mind. Then you start extracting concepts and nouns, focus on the nouns, extract them, and give everyone a box. And then start doing some initial some initial, start doing some initial relationships between them, establishing some relationships between them. Put some line between them, and then think about the multiplicity or the cardinality. Okay. Once you have this, you have a nice diagram. It captures the major concepts and the relationships between them. What you have just produced once you finish this step, you have produced the conceptual model. Why we call it conceptual model? Because it captures the major concepts in the problem domain you're trying to solve. Are we done?
Yeah, it's a question.
Yes, please.
Maybe it's a stupid question, but 0
No.
to n and 0 to n. What's it?
Yes. It's just to indicate here, if I put n and n, it might give the illusion that if, for example, if a student takes 5 sections, the section also have 5 students. If I put n and n, it might give the impression that they have to be the same multiplicity. Yeah. If I put n and m, then it says, okay, many, but this many on both sides could be different. Students can take 3 sections, but section could have 50 students, no problem. Yes? Okay. Once I do this exercise, I go to the next step, which is called,
The AR diagram.
this is already the initial version of the AR diagram. Yeah? By the way, in this domain, you could go into the theoretical stuff, and put your ER diagram like this. I've been in the field for very long. I never seen anyone doing this in practice. Okay? They just fire in practice. They either use a diagram that comes with the database. They make up their mind, I'm going with this database or that database. Or if they are a little bit more sophisticated, they go with the tool, with a diagramming tool, like let's say in this case Visual Paradigm. By the way, we have a free version. I will share with you the link if you want to download it for curious students. Let me see if I can. Okay. All right. So new. Let me not save. Create a new. Okay, no problem. Let me create new. Blank project and create a new. Sorry. How do we? It has been some time. New model. Sorry. Let me see where I start. Diagrams. Yes. Diagrams, and then I go new. There are so many diagrams. One of them is the entity relationship diagram. Okay, I pick up this one. Next, blank one, or there are many examples you can kind of see to learn from them. It comes with the tool. Let me just pick up blank one. And here I will say banner or student registration system, whatever you call it. Go ahead. And basically all I do, I put entity here. This is students, and there is, what did we say? Student and what was the student? Yes. Just want to see. Okay, let's start with a course just to keep it simple. Course, and then I have, I think, one-to-many relationship. No, I think I need to have an attribute first. Let me just put here course ID. Just to get started. So I have here a course ID. I take this guy. No, I click here. A one-to-many relationship with the entity section. No, I can create it, I think, on the fly. It has been some time since I used this. Okay, no problem. Let me create another one here. Let's say section. For me, I think to establish relationships, CRN, and it is an integer, okay? Delete. And then I'll go ahead, let me see, or maybe now I think I can connect these guys. One-to-many relationship. You see, it establishes a one-to-many relationship between the two. Maybe I don't need to. Let me see if I remove this. No problem, let's keep it simple. This is my conceptual model. You see the one I did there? I can start just with the entities without any attributes and establishing the relationships. And I can start doing this. This is student, and a student has a many-to-many relationship with many-to-many. Oh, sorry. Yeah, I think, yes, okay, I see what you mean. Yes, I got the idea. In here, like the conceptual model, usually in practice, it's pen and paper. In here, you go into a little bit more details when you start doing the entity diagram. Because in the real world, this conceptual and logical diagram, there is no kind of clear separation. So you might start with entities and immediately you start putting attributes, for example, okay? It's not like a must kind of, there is a conceptual and then you go to the logical. It's just easier to manage that way. You go from high level and you go into the details. You don't dive into the details and you get lost in the details. You start from conceptual and then you go to the details. So let me try one more time. So if I go here, if I go here, choose this many-to-many. Many-to-many, okay. Okay, you can see here, this is a many-to-many relationship. Many-to-many relationship, because remember, this is a professional tool, practical tool. It's not academic tool where it has to go through the rigorous steps. In here, many-to-many relationship is not supported by the relational model. You cannot have many-to-many relationships between two entities, okay? Once you have a many-to-many relationship, to establish a many-to-many relationship, you need another entity. We call it a bridge entity, or there's another name for it that I forget, for you to connect the two. Okay, so let me explain this, and then come back and try to do it here. So we established, if you recall, what did we establish before? That there is a many-to-many relationship between student and section. Yes? So in here, this is the student, and this is a section. In the conceptual model, if you do this, you did a very good job already in the conceptual model. But when you move to the logical model, there's no more step after that. Logical model, and then you will create your database to be deployed to the database system. When you go to the logical model, you have to break some of the relationships and make them compatible with the relational model. So the relational model does not allow many-to-many relationship. So I need to break this relationship into I put a bridge between the two, and then I'll translate it into one-to-many and one-to-many relationship. And the bridge will bridge these two entities. So what do you think? How we will break this relationship and translate this relationship from many-to-many into one-to-many? What do you think? We said that we will put a bridge table or bridge entity. Initially, and in most cases it will work for you in terms of name, all you do, put here the name of the first entity, and the name of the second entity. Initially, you might come up with a better name as you improve your understanding of this particular part. So what you do here, you say, okay, instead of linking directly to section, I will say the student will have one or many student section, and the section will have one or many students. Okay, so basically you say this is a bridge. Because it is a bridge, so what do you think? Suppose maybe we are burning a little bit of steps. Let us put some attributes just to make this clearer. So in here for the students, for example, we have student's ID of type integer. And let's just make it simple. First name of type varchar or string. And we have section. In the section, what do we have? CRN, which is a unique identifier of section int. And let's say label. You know, some section usually have label like L51 or L01 or L. Our section, I think, L01. Yes, label, which is a text basically. Okay, so what we do in this bridge table, we take, by the way, this is the key. That's another concept in a relational database. When you go to the logical model, in the logical model, you start putting attributes in the entities. Attributes are the data items, the pieces of data you care about for each of the entities. So if you take student, you say, for my application, what are the pieces of information about student that I care about for my application? Okay, and I start, some of them will be in the requirements, in the requirements analysis. Because, for example, when a student when student enrolls or come to QU, for example, and submit their application or become a student, they collect a bunch of information from them. And those information we collect when we first create a student are the attributes of the student. Let's say ID, first name, last name, email, phone, address, and so on. Okay? But one of the attributes, we have to select one of the attributes to be a key. What does it mean, the key of the attribute?
Unique
address.
It's basically a unique identifier, something that uniquely identifies each instance of the entity. Okay? So because remember, here, if you are coming from an object-oriented background, here we are creating classes. And then, based on these classes, we will be creating objects. In the database world, we will be creating, these entities will become, in the database, they will become tables. Okay? Don't get this term to confuse you if you are new to this. It's just terminology. At design stage, because we are doing now the design, at design stage, what do we call them? Entities. When we create our table, our database, when we take the entity and create it in the database, we call it table. Okay? It's the same thing, exactly the same thing. Now, once I create the table, what I start doing? Inserting rows into the table. Yes? Each row must have a unique identifier. Why it is a must to have a unique identifier?
Redundancy.
No, basically to be able to retrieve it by ID later on if I wish, and to be able to link with other entities. Yes? Because remember, this student's ID, we will be using it in other entities to be able to do the linking. So for the linking to take place, I must have some unique identifier. So every table must have a unique identifier. In fact, in databases, if you don't put unique identifier, database will generate one for you. Not visible, not accessible to you, but it will generate one. Okay, so it's a required thing. Okay, so, and guess what? What will happen here when I have this bridge table? How I will connect these two tables that have a many-to-many relationship?
The unique key from
By the keys. So what I do, I take this key from each side. The keys of both relationships, keys for both entities linked with the many-to-many, I bring them to the bridge. Okay, so what will be here? What I'll put here? So the ID, which is int, and the CRN, which is int. Okay, so this way I can have, you see here, one-to-many. So I can have one student can have many CRNs. Yes? And if I look at it from the other side, one CRN can have multiple students. Okay? And the relationship becomes what? Students can have, of course, it is 0 to n, and the course can have 0 to n. N is okay now because we don't have this confusion. And then section student, what's the relationship with the student? 1. It cannot exist without having a student. Yeah, must be linked to a student, otherwise it cannot appear here. So the relation becomes 1. The multiplicity becomes 1. And here, can I have an entry here without being linked to a section? Every entry in this section, in the student section, will be linked to one section. Yes? So basically, when I have a many-to-many relationship, I cannot, in the logical model, I have to break down this many-to-many relationship, put a bridge table between these two entities having a many-to-many relationship, and initially mechanically, I take the primary key of each of the entities and bring them as attributes of the bridge table or the bridge entity. Yes? And by the way, this becomes, what is the key of this bridge table or bridge entity?
combination.
Is a combination. The key here is a composite key. The key here becomes composite. Because if I just take the key here, if I take the key as the ID, and if only the student's ID, if the student takes multiple courses, it will repeat. Then it's not unique anymore. And the same thing, if I just take the CRN as the key of this bridge entity, the CRN will repeat because multiple students will take the same section. So it will repeat. For us to be unique, the key will be a composite key made up of the two. Yeah? Yes, please.
Can you use a third key, just a new key?
Now, this is a good question. Like initially in the logical design, we go for composite keys. Okay. Now, when we do the actual implementation, we might add another key, theoretical key that gets auto-generated. Okay. But we still need to be aware that there is something unique that identify every record, and typically that key is a composite key for the bridge entity. Now, if I wish, especially if this bridge entity is linked to other entities, if I don't want to repeat this, composite key in the other entity, I can create another, what we call surrogate key, which is a theoretical key. Okay? Like, for example, in here, what is a better name for student section? Do we keep it student section? Registration could be a much better name. Yes? But initially, don't go into that land yet. Initially, when you have a many-to-many relationship, break it, do it mechanically first. Do it mechanically first. How do we do it mechanically? Take the name of the first entity, underscore the name of the second entity, take the primary key of each entity, and put it as attribute of this bridge. Okay? And then have another think about it again and say, is this a good name or there's a better way of expressing this? So in here, the student section really is what? Registration. So I can remove this and call it registration. So this is how these two entities are linked. Students can register sections, and section can be registered on or can be taken by students. And by the way, this bridge entity can have its own attribute if we wish, such as in this context, what could we add here? The date of enrollment. I can put here enrolled on, and this is type date. Yes, I can do that if I wish. Okay, so now because I'm using a tool here, let me just remove this. Because I'm using a tool, it basically does it by itself for me. So I can take this one, many to many, bring it here, drop it here, and automatically it creates this bridge entity. Yeah? And then I can move on and continue, okay? Yes, please.
So in our projects, we will do all of these steps?
Yes, you will do these steps, yes. You will start with your use case. And hopefully by next week, please bring your use case so we can discuss them. Make sure they make sense, make sure they are reasonable, they have some reasonable level of complexity, because the use case needs to be somewhat reasonable, so it has some opportunity to do some queries, something with the database.
So after...
In the use case, sorry, this is a very good question. By the way, in the use cases that you will bring, hopefully next week, make sure you have some of them are kind of reports. You remember in many applications, you always have reports. For example, in Banner, you might have a report that says, give me current enrollments of all sections, or give me sections that are closed, or give me sections that are empty. This is a report. It gives you all the sections and how many have enrolled and what is the capacity. And the ones that are, you can filter, okay? Have some use cases that does some aggregation of data in a report. So when you do the SQL and you do the implementation, you will practice this. Don't bring only use cases that require inserts, updates, and so on. Have those, of course, but also have some reporting use cases, because 99% of applications you always have reports that aggregate things and give the big picture. Because managers, this is where managers like admin, they might have access to reports. They don't care about the details. They just want to see the big picture, how we're traveling. Are students registering, or they are still keeping it to the last minute? Are the sections full? Do we need to create new sections? Do we need to... So administrators, that's what they are concerned with. Okay, do we have enough classrooms and so on? And to help them make decisions, what they need to make decisions, they need reports. And reports will come out from your system. Okay, so yes, you will go through this process from use cases to design to implementation and so on.
After this, we will translate this to the...
Yeah, I will show you. I will show you shortly. But the conceptual model is clear. The conceptual model. You come up with entities. You find out the relationship between them. You put your cardinality. If you want to use the database terminology, cardinality, or if you want to use the object-oriented terminology or UML terminology, it's multiplicity. But the same thing. Very important piece of information that you need to put in your diagram. Okay. Now, once you are done with this, then you start defining your attributes for each of the entities. Each entity, you will go and start putting the attributes. For example, here, course, let's say ID. Just keep it simple. In here, because here in the logical design, typically in real life, in a logical design, you have already kind of targeted some kind of database. Okay, so because in the database world, the data types are not standardized. There are few kind of differences between one database to another. But it doesn't matter at this stage. But realistically, because there is no more step, from this diagram, you will go and deploy it in your database. So theoretically, they will say, okay, just put the attribute later on, worry about the data type. No, you do it in one exercise. What is the attribute? What is the type? What's the attribute? What is the type? Okay? And then you say here, first name, first. Now, in here, there is a lot of dilemmas again for the naming. Naming, the rule is that meaningful name, must be meaningful name. Now, in here, the name, even the name in the database, this is, I mean, what I'm talking now, I'm talking from experience. Databases have slightly different behavior. If you are using SQL Server, it preserves the camel casing. It preserves the way you write it. For example, here, if I put first name, and I make it a varchar 50, yeah. If I am targeting SQL Server, this column name will be kept as I put it in the diagram. If I am targeting Oracle, unfortunately, it puts everything uppercase.
Yeah.
Okay, and then you end up with names that are hard to read. Okay, so if you have in mind you are targeting Oracle, from day one, put it like this. Yeah. So because the naming is based on the community you'll be dealing with, or this is the Oracle people, they are happy with this. If you do this with this SQL people, they will say this is an Oracle guy came to our team. Yeah, because in SQL, take a look at this. In SQL, you can have camel casing, where camel casing, which means the first letter of every word is uppercase. It preserves that. My server is have some problems. Let me try to connect to the local one. Let me find out the host name. Host. Is it host name? Yes. Okay. I think we do it like this. Is it like this? SQL. Yes, SQL Express. Then I do this. Let me see. Hopefully I can connect. Yes, I connected to the local one. And if I go here, for example, and create, for example, I can create here, let's say new table, just as an example. And I'll go and say, let's say first name, varchar, or this name will be kept as you typed it. If I save this table and make it, for example, student section, no problem, it will be remaining as you decided. But in some other databases, it puts everything uppercase and makes the naming much harder. Okay, so the naming, you see here, practically in practice, when you go to the logical design, you already have some database in mind, because you start customizing your naming, your data types based on the database you have in mind. Yes. In fact, even in the tool, let me show you. Even in the tool, I think, let me see if I can find it. Tools. Yes, even in the tool, you go here in database and you say database, you configure the database. And basically what you do is you select the database that you want. And you even connect to it. So when you select the database, the tool, which is in this case the Visual Paradigm, will start giving you the data types of your target database. Okay? There are small differences. There is int everywhere, but some of them have slightly different naming. Okay? Okay, so let me see if I can. By the way, since I am here, okay, because of the time, let me now just jump here quickly to the diagram, create new one, go to entity diagram, go next, and then I'll just choose one existing one just to show you the complete story. Let me Let's just take this one, video rental system. Open this. Next. Okay, this is a video rental system. So I have my entities here. This is a customer. These are the major entities. This is a customer and this is a movie. And this is producer. Now a customer can rent a movie, and a movie can be rented by multiple customers. Okay. How come it can be rented by multiple customers? Date rented, due date. I see. Okay. Yeah, because this is kind of a historical table. This bridge table, it keeps the history of rentals. Yeah. So same movie can be rented by many customers over time, of course. Not at the same time, over time. That's why we have here date rented and due date. Anyway, what I want to say here, you go ahead and start defining your attributes one by one. And then one of the attributes you can make it as primary key. So I think you right click and say including primary key, and then it becomes a composite key. You can see here automatically, because this is a bridge table. Can you see it? The primary key that I added was added here. Remember the bridge table that connects, that's break down a many-to-many relationship to make it feasible in a relational model. The bridge table, by definition, or the bridge entity, by definition, what it will have? It will have the primary keys of both tables. Yes? Okay. All right. Moving on. So let me just remove this one. So you can change the you can basically, here you are doing constraints. You are defining the constraints on your columns. You can say by default is a mandatory. It's not null. If you want to make it optional, you click this one. So no, sorry, this is unique. This is nullable. It can be made null. I think nullable is by default nullable. But you can, if you wish not to make it nullable, you can remove it. You can make it unique. Don't worry about index at this stage. The main ones you will be using, primary key, nullable, maybe unique. Those are the main ones you will be using. Okay. Okay. Once you are done with all of this, all you do, you go to Tools, go to DB, and you do Generate. Okay. And in here, what you can do is, before you do that, what you do, you configure your database. Which database are you targeting? For example, here, my SQL Server. For some reason, I'm not able to connect to my server. Let me try.
So should download this application before?
You can choose, by the way, you can choose any database you wish. I think it's back. Sorry, I'll show you exactly right now.
You should have like the server of the SQL.
Yes. So remember, this is a design tool. And then from design, this is the power of modeling. Once you model, you spend a lot of time doing this. You could have done it on pen on paper very quickly. You have spent time putting it. It pays off. You can generate from here your database directly. And by the way, you can generate the script and you can run it immediately and you create your database immediately. Okay? So let me show you this super quickly. So if I go to here and I select my SQL, and then here I put here cse.qu.edu.qa, and I think 1433, I think the port. And here I put, for example, let me create a database. Let me go there and create a database. New. Come on. Create a database. I call it rental. movie rental DB. You can use any database you are familiar with or you are comfortable with. I'm using SQL Server because I'm familiar with it and it's simple. Okay. So it goes ahead and creates a database. This database is empty. It has nothing. So if I go here, there are no tables, nothing. It's just empty database. There are no tables there. Then if I go to my tool, and then I'll say here rental, what did I call it? Movie rental DB. Movie rental DB. Test. Test is successful. I can connect to my database. Close this. Now I am able to connect to my database. Let me remove this guy. Okay, this is fine. Now what I will do now, I go here to my DB menu, go to generate database. Now it will be generating this database, and I will say here export to database. If you just want to create the SQL, it will create the SQL for you. If you want to immediately go ahead and run it, you can go ahead and do so. Run it, and you can go and do okay. Model contains errors. Ignore and generates. Okay, ignore for now. No, didn't like it. Contains some errors. No problem. Please give me a few seconds. Let me create new one. I used one that's okay. Let me take this one. Pick one. Movie rental. Go ahead. Here's the movie rental. Okay, and then I'll go to my tools. Generates, and let's hope now it will work. Test the connection. The connection is fine. Okay. May already exist. Is it movie rental? Yes. Okay. All right. So it went ahead. So if I go now to my database, refresh this, I get here my tables, okay? My course, my customer, movie rental, movie producer, and so on. And I have also the relationships. In fact, in here, if I go and create new diagram, this diagram is built in the database, in SQL in this case. It comes with the relationship that I put, everything will be there. So let me show you. And it also from the database, sorry, from the ER diagram, you can create class diagram. And if you want, you can create Java code or C# or whatever code you want. Okay, so that's the power of modeling. You can go for, because a model can be translated to another model. In this case, a text, it can be translated to SQL or to Java or to any other language you want. Okay, this was all auto-generated from the diagram that we invested time building. And do add. So I'll get all the tables that were created. And not only this, I also get the relationships between them. You can see here, just to show you, like you see Microsoft's diagram, they use a different notation for the relationship. So this is a one-to-many relationship. Yep, that's basically the idea. Okay, what else I want to say? Yes, from here, if I wish, I could also go to code and generate Java code, which are basically classes that represent each of those entities as a class. So I can get started from there. Or I can even generate, I think I can generate a class diagram. Where is the class diagram? Generate code, reverse. Yep, there is. I tried this before. Definitely, it can generate class diagram from here as well. Sorry. Synchronize to class diagram. I think if I choose this one, Yeah, see here, class diagram generated from the entity diagram. This is just to tell you, these are وجهان لعملة واحدة. This is the same thing, class diagram and entity diagram. They are really connected. Of course, class diagram has much more. In the class diagram, you can add methods to classes. In entity diagram, you just stop at the data, the attribute that the entity will be storing. The entities don't have any don't have any functionality associated with them. In class diagram, there are more, you can do much more. Yeah? Okay, that's it. I think I'll stop here. So what I mean, sorry, I just want to say one more thing. In this domain, there are a lot of theoretical stuff that you can go through. But in practice, what I kind of showed you, although very quickly, is the way people do it in practice. Okay, they don't do this stuff. In my experience, I never seen any database professional using these notations and doing this conceptual model this way, especially this one. If you do this one, they will say this is definitely just came from a database course. Okay, you don't put a composite attribute in your diagram from the first place. Okay, in theory, okay, you have this conceptual model, you have a composite attributes, and it have kind of sub attributes. In practice, you do it immediately. From day one, you put in your mind all attributes are atomic. You can only store one piece of information. Yeah, from day one. So you don't even fall into this. And also, like an attribute can only store one value, cannot be multiple values, cannot be an array or cannot be a repeating value. Must be one and only one. If you have multiple, most likely you need another entity and you have a one-to-many relationship. Yeah? So you keep those in mind, and then there is another thing, I will discuss it next time. There's something called normalization, which you go through and refine your model to remove redundancy. If you do the practical approach I showed you, your model is already normalized. You can go and normalize it if you want, and I will discuss with you later. But if you just follow common sense and put these principles, I try to summarize them in some slide, put them in your mind as you design, then you won't have anomalies that you will go and waste time removing. That's how, basically, the way I showed you, that's how people in practice just do it. Yes? Okay, thank you.